systems of equations problem, as it says right there, and it says, what is the solution? So we're trying to find an x and a y that if you plug it into these, both of these equations, they're both true. So I plug a certain x and y in for the first one and work it out, it should be equal to negative 23. If I plug it into the second one, it should be negative 19. And the easiest way to do this, I try to start with the easiest way first, is actually just trying all of these in this value. Okay, so that's what I did. So if you plugged in negative 5 to the first one, it's 3 times negative 5 plus 4 times negative 2. And then you work this out. So it's going to be negative 15 plus negative 8, and that's equal to negative 23. Okay, so it works for the first one, but it has to work for both of them. So now we're going to do the exact same thing, only with the second one. So now it's going to be 2 times negative 2 minus negative 5. And we're going to have negative 4 here, and then this is going to be a plus 5 to be a 1. So it's not going to be A. Okay? Because it works for the first one, but not the second one. Let's try B. If you plug in 3 to the first one, you're going to get 9 plus negative 8 times 4. Whoops, I should have just wrote negative 32 then. And that is equal to negative 23. So the first one works. Let's try the second one here. Let's see here. 2 times negative 8 is negative 16. So it's negative 16 minus x, which is 3. Make that a negative there, and you end up with negative 19, which is the correct answer. Now, if you tried the other ones, they wouldn't work, okay, because there is only one answer on these. But and rather than wasting time doing that, you can kind of do that on your own. But that's the fastest way to do this because it's multiple choice, and you already have the possible answers there. But say it was a free response problem. I will show you how to do that as well. The easiest way to probably do this is, I mean, I guess you can do elimination, but I'm going to use substitution because it tends to be the way that most people know how to do it. So for substitution, what you can do is you can solve for one of these. Let's solve for x because it's by itself. Okay, so we have 2y minus x is equal to negative 19. So what I'm going to do is to solve for x, I'm going to add it to the other side and add 19. I'm going to add x to both sides, and then I'm going to add 19 to both sides. So adding x, adding 19, adding x, adding 19. You have to do the same thing on both sides, okay, because of the equal sign, equal rights. What you do to one side, you have to do to the other. All right, so then we're going to cancel this here, and you're going to be left with 2y plus 19. Here, the 19 is going to cancel, and you're left with x is equal to 2y plus 19. So now what you can do is take this x and plug it into the first equation's x right there. So now it's going to be 3 times x, which is 2y plus 19, plus 4y is equal to negative 23. Distribute this out, you're going to be left with 6y plus 30 plus 27 is 57 plus 4y is equal to negative 23. As you can see, this is way more work than just testing the numbers. You're going to have 10y here if you add this and this. If you subtract off the 57 to the other side, you're going to be left with 80, negative 80. Okay. Which is good because that is what the answer you should get for the y is negative 8. Divide both sides by 10 and you get y is equal to negative 8. Okay. Then you can see over here which one of them actually has a negative 8, only one of them. But say, it was free response. You can use this x equation right here to figure out what the x is. So plug negative 8 in there. You're going to get negative 16 plus 19 to get 3. So your final answer from this would be 3 comma negative 8. Okay, but I had to use substitution for this rather than testing the values. This is finding it algebraically versus finding it numerically with just the numbers.